That's why we stopped on Wednesday. We discussed with you matrix multiplication. It's not a trivial operation, and we're going to study this for a while. Actually, I chose quite a range of tutorial questions to demonstrate interesting properties connected with the matrix multiplication. I'll quickly remind you what happened. When you multiply two matrices, before you even start thinking how to multiply them, you have to make sure they are of compatible size. And when I say compatible size, it means that the number of columns in the first factor must be identical to the number of rows in the second factor. If it's not, then that's it. The multiplication, the product of A and B is no longer defined. It's not defined, sorry. If it is so, then the resulting matrix will be of size. You see, number of rows in the first factor, number of columns in the second factor. And each individual entry in this product requires substantial computational power of your brains, I mean. You see what you do? For every element, you choose like if the element sitting in the jth column, in the jth row and kth column, you take the jth row from the first factor, you take the kth column from the second factor, you look at them as vectors and you dot product them. This is structural description, how we multiply the matrices. And I gave you this demonstration. For instance, this element, -8, third row, first column, I chose third row from the first factor on the left, first column from the second factor. I look at them as vectors. Both vectors have 3 components, and I dot product them. If you do that, the result will be -8. And you do this dot product as many times as you have entries in the result of your multiplication. It's an intensive computational task. Even for computers, it is intensive computational task. Now, the question which I didn't raise on Wednesday is that what happens if you just change the order of factors? For instance, in this particular example, if you take B times A, this time you no longer will be able to compute the product because number of columns in B, 2, is different from the number of rows in A, 3. It's the first time in your experience in mathematics you see something which is what we call non-commutative. You change the order, it doesn't make sense anymore. In fact, my next example will prove you that even if it does make sense, even if you choose the dimensions of your matrices in a way that both products AB and BA make sense. For instance, you can start with a square matrix. So the matrix which has identical number of rows and columns. If I have square matrices, then both products, both orders, AB and BA, they will make sense. They will be square matrices of the same size. So there's no problem with making them compatible. They are compatible. However, even in that case, by changing the order of factors, you may change the result of the multiplication. Here's the example. Here's my example for A. Here's my example for B. This time, if I have these two factors, the products AB, BA, they will make sense. It will be matrix 2 times 2. But if we start computing that, look what's going to happen. I claim, I will take you through the computations partially, but right now I just claim that AB will be the matrix like so, and BA will be the matrix like so. Let's just double check that. Let me just take this red box. For instance, this element, 15. In the product like so, that's the element which sitting in the first row, first column. So I have to take the first row in my first factor. And I have to take the first column in my second factor. If I dot product these two vectors, 2 times 9, 18, take 3, it is 15. Now, if I look at the corresponding element in my BA product, look at this, 22. It's the element which sits in the first row, first column. So when I compute the product, I should take the first row in the first factor, and this time it is B. And the first column in the second factor, this time it is A. If you dot product these two vectors as vectors, 2 times 9 is 18, but this time you plus 4 it, which is 22. Surprise, surprise, it's a different result. I'm not going to take you through the rest of the entries. You can double check them yourself. Just one entry is enough to support my claim that if you change the order of factors, the result may change. Just one, if only in one entry. If it changes in one entry, it's enough to say that it just changes. Any questions, please? Now, I'll tell you this. Quite unexpected behavior of the matrix product. It's a source of all troubles with matrices. Not only for your troubles, you will have troubles with it, grasping this problem, but also for the industry and applications. And that's why, like in linear algebra, they develop lots of different techniques and methods how to deal with this problem, that we no longer can change the order of factors. Probably I won't be able to expose to you the full extent of the difficulties which arises from that. It just only comes with the experience. The longer you spend with this, the more you will understand. But some of these difficulties you will probably realize in the course of your tutorial, so together with me. Now, before we proceed, let me just discuss some basic properties of multiplication. Like with any other operations, there are some basic properties we're going to rely on. Well, at least now we know we have to cross out the commutative properties out of the list of the properties we're going to rely on.